Okay guys, we're going to start with section 10.6 in this video. The main thing in 10.6 that I want to go over in this video is solving radical equations. Guys, if it's called a radical equation, it's because it's got a radical in the equation. So you can kind of see this example down beneath. In order for you to solve a radical equation, you need to make sure that the radical expression or portion of the equation needs to be by itself on one side of the equal sign. So this one is already set up that way. The radical expression is the square root of 2x plus 9, and it's by itself on the left side of the equal sign. So that part is taken care of in this problem. But that is the first important step to make sure of. The second thing you need to remember is that when we solve equations, we use opposites. So therefore, we need to know the opposite of the square root. The opposite of the square root is the square power. So once you have the radical expression isolated on one side, like we do here, you can immediately square both sides of your equation. Remember, what you do to one side of an equation, you have to do to another. So when I square this side, and the reason I do that is to cancel this radical portion, you know, those two things are opposites. So, but what I do to one side, I have to do to the other. So on the left side, it's going to cancel the radical, which is just going to leave me with 2x plus 9. But on the right side, I have to do 5 squared, which is 25. At this point, it becomes a regular linear equation that we can solve easily. Minus 9, 25 minus 9 is 16. And as I keep going to solve this equation, I'm going to have to divide by 2. And I get x is equal to 8 for this particular problem. Okay? Now, because we're doing radical equations, you've got to check your answer. Okay? This is something that we have to do for radical equations, just to make sure that it works. So I'm going to plug in what I got to the original problem and make sure it checks out. So that would be 2 times 8 plus 9 under the square root should equal 5. Well, 2 times 8 is 16 plus 9. So this is the square root of 25 is equal to 5. And that does work. 5 equals 5. So that means that this is correct. And I can use that as my answer. Okay? Guys, every once in a while you get problems where the answers don't check out. So for radical equations, you need to at least mentally check your answers. Sometimes it's easy to do that in your head. If not, you should write it out. Alright, I want to do 2 more examples because this is probably the easiest type of problem that you'll see. When the radical is already by itself on one side and solves pretty easily. So I want to talk about one other example where the radical is on one side, but it's still a little more to it. So what if we had x is equal to the square root of 13x minus 22? So this is slightly different because I have an x on one side of my equation instead of a number, but that's okay. I still have the radical portion of my equation on one side, so that's good to go. As long as that radical expression is by itself on one side of your equation, you are ready to square both sides. Okay? Well, this time when we do that, on one side I just have x squared. Okay, that's all I can do over there. I know on this right side, I can cancel that radical with my square exponent. (13x minus 22). Well, now we don't just have a linear equation to solve. Now I have an equation that has an exponent in it. And remember, we learned in chapter 6 that anytime you've got an equation that's got an exponent on any variable, you've got to have all of your terms on one side of the equation because we need to set it equal to 0. Okay? So here I'm going to do minus 13x, positive 22, positive 22. Because I need to set this equal to 0. Okay? I've got to set it equal to 0 because of this exponent. Alright, so now that's going to give me it's going to give me x squared minus 13x plus 22 equals 0. So hopefully, guys, you recognize that because I've got this exponent, I also have a possibility of 2 answers. Right? Because when we set a trinomial with leading coefficient 1 to 0, I know that the next step is to factor and set those binomials equal to 0. So here I'm going to say, well, I know I need to factor. So what multiplies to give me 22 and adds to give me negative 13? Okay, that would be 11 times 2 is 22, and negative 11 and another negative 2 would give me negative 13. So if you'll remember, we're going to put those in to 2 parentheses. You should see that if I FOIL this back, I will get x squared minus 13x plus 22. So both of these need to be set to 0, right? So that means I've got x minus 11 equals 0 and x minus 2 equals 0. So that's going to be plus 11. So I know this gives me a positive 11. I'm going to add 2 here. So I know that gives me x equals 2 as another answer. Possible answer, right? The reason I say possible is because you've got to remember to check your answers. Okay? So I've got to check by plugging in the original equation. So let's check and see. So for first I'm going to check the 11. So 11 equals the square root of 13 times 11 minus 22. The other one I have to check is 2. So 2 equals the square root of 13 times 2 minus 22. So I got to check both of those. Well, 13 times 11 is 143. Minus 22, which is 121. And I know that that works. So that one checks. Over here I'm checking my 2 answer. Well, I know that 13 times 2 is 26 minus 22. And that's this 26 minus 22 is 4. And I know that the square root of 4 is 2. So both of the answers check out in this problem. So both of them are solutions to this equation. Sometimes one will check and the other one won't. I've even, you just always have to make sure you check them. I've seen very few cases where neither of them work. Okay? All right, let's try one more. This one is going to be the most challenging type of radical equation that you should see, that you should ever see. So we're going to do the square root of 30 minus 2x plus 3 is equal to x. I hope you notice right away something different about this problem. One of the steps that we need to make sure of is definitely not done here. The radical portion of your equation is not by itself on the left-hand side. The square root of 30 minus 2x needs to be by itself on one side of the equation. This plus 3 keeps it from being by itself. So now this is the first time we have to make that correction, or that change first. Minus 3 minus 3. That way, all I have on one side is the square root of 30 minus 2x. But now on the right side, I have x minus 3. Okay? Well, we know that the next step has to be to square both sides. And the reason we do that is to lift the radical off of the equation. So nothing new about that part. On the left side, I know I'm going to have just 30 minus 2x. But what about the right side? X minus 3 squared. That's a quantity squared. That means off to the side, I need to do x minus 3 times x minus 3. And FOIL that out, which gives me x squared minus 6x plus 9. Okay? So that's really the biggest difference. Whenever you've got to move a term and get the radical by itself, you're going to have this possibility of foiling on one side. Once you get through with that, you've got an equation that's got a exponent in it, a square. So I know I've got to move things over and set it equal to 0. I also know I want to keep this x squared, this leading coefficient, positive always. I don't ever want a negative x squared. So that helps me realize that I need to move the 30 over, so I need to subtract 30 from both sides, and I need to add 2x. So that I can have this set to 0. 0 equals x squared minus 4x minus 21. Okay? So now we have a similar situation to the last problem. I need to get these two answers. I need to factor this. So I need to know what multiplies to give me 21. And you guys know that I do this subtract thing whenever this is a negative. So subtract to give me 4. So that's 7 and 3 But I know that whatever this sign is, whenever this is subtraction, the negative 21, I know that I have one of each sign in my answer. And I know that the largest of these two numbers down here should match the middle term. So this needs to be a -7 and a +3. -7 and +3 give me -4. And -7 times +3 gives me -21. So that gives me 0. And I'll have x minus 7 and x plus 3. So we set each of those equal to 0. So we get x equals 7 and x equals -3. But I know I have to check both of those. Okay? So when I check them, I always plug in to the version of the equation that the radical was by itself. But a lot of people are used to plugging into the original equation, so we're just going to do it that way. You really can plug in to the original, or you could even plug in to that one if you wanted to check. So I'm going to check these. So square root of 30 minus 2 times 7 plus 3 equals 7. So that's one that should work. Well, this is going to be 30 minus 14, right? So that's going to be the square root of 16 plus 3 is equal to 7. Well, that works because that's 4 plus 3 equals 7. So that one works. So I can draw a nice box around that. It checks. So I'm going to try the other one. 30 minus 2 times -3. Then plus 3 is equal to, there's another x there, so -3. Alright, so this is 30 plus 6. So I know that's the square root of 36 plus 3 is equal to -3. So 6 plus 3 is definitely not -3. 9 does not equal -3. So this doesn't work. So we put an X through that answer. Okay, this one only has one solution after you check it. I wish I could tell you it always works out that way. Sometimes it doesn't. Some people will say if it's negative, it doesn't work. But that's not even always true. There are cases where a negative answer will work. It really just depends on the setup of your original equation. So that's why you should always at least mentally check your answers and see if they work out. Okay? So that's solving radical equations. I'm going to be back soon with your overall review lesson for Chapter 10. It'll include some applications and just some test review items. All right, I'll see you guys soon.